I'm interested in how to create good charts. By a good chart, I mean something that can be quickly and accurately deciphered. I'm going to very briefly look at how we comprehend charts. Then I'm going to go through a series of cognitive limitations that affect our ability to process charts and techniques for improving data visualizations that arise from these limitations. When we see a chart, we observe things. We note that we have squares, which we interpret as heights. We've got colours. We translate them. The height of the columns, we believe, are ratio scale measurements of something. The colour denotes different series. We associate these translations with things external to the chart. So the height of the columns is seen as being the Net Promoter Score. The different colours are seen as being performance of two different banks over time. And then we make inferences. We notice that the blue bars are consistently higher than or equal to the red bars, which tells us that Bank A consistently outperforms, or at least is on parity with Bank B. If you focus on each of those four stages, you can come up with some pretty obvious conclusions about how to improve charts. This is a very common children's book in the English-speaking world anyway. It's called Where's Wally? And it leads us to our very first conclusion, which is that if you want to create a good chart, you need to maximize white space. Now, this is in no sense a new conclusion. It's the classic one that appears in the academic literature, and I'm going to take you through 9 conclusions, and they're going to get a little more novel the longer we go on. Here I've got another chart, or I'll shortly have another chart up. This is showing some Australian polling data. It's been created by a couple of graphic designers. It suffers from the problem of Where's Wally, in that there's a whole lot of things designed to look attractive, maybe not attractive depending on your view, but they distract us from the data. If we have the goal of maximizing the white space, we end up with a chart like this. A lot less interesting to look at perhaps, but one which puts the data front and center. Now, a chart like this has been created by focusing on formatting, and formatting is one of 2 strategies we have available to us when we create a chart. The other strategy is to actually change the data itself. And technique 2 is to simplify the data. And there are lots of ways we can do this, such as rounding or aggregating data, and in the case of time series like this, we can smooth the data. And the reason it works is you have fewer movements in the chart, which means there are less things to observe, which makes the whole process of interpreting the chart easier. Here we have another example. We've again taken the chart on the left, it's been turned into the chart on the right. It's simpler and easier to read, but the key thing that the chart on the right has, which the one on the left didn't have, is commentary, designed to make it easier for us to spot the key point that is being pointed out or emphasized by the chart. Now, everything that I've looked at so far is pretty obvious, but it's the less obvious things which I think are most interesting. When we create a chart or a plot or a visualization or whatever term we want to use, we have at least 9 graphical dimensions we can play with. The first 2 are the vertical and horizontal position with which we put marks on a page or a screen. There's colour as the next dimension. We can look at the shape of the objects that we put onto the screen. We can look at the degree of intensity of the shading or the luminance. We can look at the orientation or rotation of objects. We can play about with size. We can make things blink. And we can use movement. Which all leads us to the question of which dimension should we use? Now, I'm going to do a little experiment with your brain to let you come to the conclusion about which dimensions are best. I'd like you to spot the odd one out. And do it again. And once more. Now the two images on the left were really easy for you to spot the odd one out on. On the far left, you don't even have to think about it, it's immediately obvious. In the middle, again, it's immediately obvious. On the right, it was a little bit harder, and I've actually shaded it because from previous experience, I know quite a few of you will not have spotted the odd one out. And the reason that it's more difficult is because the image on the right is in 4 dimensions. There's the vertical and horizontal position of each of the objects on the page. Then there's colour and orientation. And our brains are really only good at doing 2 dimensions and perhaps 3. When we get to 4 dimensions, it's harder. Sure, we can figure it out, but it's harder work. And if it's harder work, it'll make any chart hard work. So the first key cognitive limitation is that we're very poor at processing information in 4 or more dimensions. So which dimension should we use? Well, thinking about colour. What you've got on your screen now may be hard for some of you to read, and if you're colourblind, it's impossible. And the reality is we're actually quite poor at processing colour. It's common to read how colour is so important to people and they couldn't live without colour and so on, but colourblind people get through life really well. People who can't distinguish between up and down don't. So we'll take colour out of the picture. Can you see a pattern here? What about here? I'm sure you can see it here. It might surprise you to know that the 3 patterns here are all equal in terms of the strength of the pattern in them. Each of them contains a perfect correlation between 2 of the dimensions. In the one on the far left, there's a perfect correlation between orientation and shading. Flatter blocks are darker. In the middle, there's a perfect correlation between the vertical coordinate and shading. Higher up, blocks are darker. On the one on the right, there's a perfect correlation between the vertical and horizontal coordinates. So in each case, the pattern is equally strong, but the only one that's really obvious to us is the one on the right. The one in the middle, we can kind of see. The one on the left, we've actually got to work to find. And so my earlier conclusion about colour was premature. The reality is we're actually poor at dealing with anything other than the spatial dimensions. Which of these bars is longer? And now? What about now? Studies have found that we're best at perceiving vertical differences. It's not as strong as an effect as the ones we've talked about so far, but we're consistently better at vertical distances, followed by horizontal, and other angles a little bit worse. And so the third limitation is that really, when we're looking at the spatial dimensions, we like them to be vertical and to an extent horizontal. Some obvious conclusions about charting follow from each of these limitations, but the really interesting things come about when we question why we have these limitations. On the next chart, which is hopefully going to appear very soon, you've got 3 seconds to remember what's on the screen. 1, 2, 3. How'd you go? I know market researchers are pretty clever, so I'm sure a lot of you have got it. But I couldn't do it. We'll do another one. Again, I'll give you 3 seconds. Now, if you can remember Chitty Chitty Bang Bang. Ray, do you want to put your speaker on pause? Okay. If you remember Chitty Chitty Bang Bang, this one is really, really easy for you to read and remember, whereas the previous one was virtually impossible. Now, the limitation here at first is going to seem obvious, and it's that it's harder to process unfamiliar information. But when we create a chart, you're thinking it's always going to be unfamiliar information. And we'll come back to that in a bit more detail in a second. Now, the reason that pie charts work really well is because at an innate level we get them because we spend our lives looking at proportionality in the same way, be it on pies, cakes, or segments of oranges and mandarins. Similarly, when it comes to height and columns, we understand these as piles, be they piles of bricks or piles of money. We just innately get what a column chart represents, and this is why we can get so irritated when people change the y-axis, because they're changing the fundamental belief that we have about what a column has to represent. Similarly, lines and slopes are things our brains spend our lives decoding and looking at, and so we're very good at doing it. And the fifth limitation, the one that's really the most interesting, is that when we examine familiar shapes, we like to draw standard inferences from these shapes. And the corollary of this, which I'll demonstrate to you shortly, is that when we see patterns we don't recognize, or we see them out of context, we find them really difficult to process. So returning to the example that we're looking at before, on the left, we do not expect to see trends in piles, which is why the column chart on the left needed commentary. Although you can see the pattern in it if you look at it, and if it's pointed out to you, it doesn't jump out at you. Now look at it shown as a line plot on the right. The pattern is incredibly obvious. There's no need for commentary. You can remove the commentary because your brain automatically connects the dots and sees the pattern. So the third technique for improving data visualization is to identify the pattern before you work out how to display the data, choosing a data display designed with a particular pattern in mind. And this is quite different to how we work in practice. In practice, we tend to think that certain types of data should be represented in certain ways, proportions as a pie chart and so on. Whereas the better model is to think that patterns should be represented in certain ways. The fourth technique, and don't worry, we're going to get to some much less obvious techniques soon, is to harmonize graphical elements. So the chart on the left is a standard line chart. But when you look at it, it actually is a bit of hard work, because initially you see the pattern, but to work out what the pattern means, you have to go, okay, the blue line, is there another blue line? Yes, there is. That blue line's next to some text, that means they're related. Now what do they mean? I'll go across to the y-axis on the left. Whereas the plot on the right, instead, it's putting all of the information in such a way that it's quite harmonious. Our brain instantly gets which bits are aligned with which other bits. Technique number 5, and this is quite an interesting technique, is to bank to 45 degrees. The idea here is that our brains aren't very good at perceiving patterns in near horizontal or near vertical slopes, and so we should adjust our charts so that the lines on the chart, or whatever other patterns may be, are close to 45 degrees. So I showed you some election polling data a little bit earlier. It's shown here again. Notice that most of the lines are nearly vertical. When I bank it to 45 degrees, I get the chart on the bottom. It is much easier to see a pattern in the chart at the bottom, and we get a second really great benefit for free, which is that the chart on the bottom takes up very little space, so we have a whole lot more room for commentary. So it's kind of a double win. Everything I've looked at so far have been kind of obvious things which I've used to describe certain phenomena about how we think and how we should create charts. I'm now going to look at some much more complicated charting problems. Here we've got 11 time series looking at Net Promoter Score for different brands. It's a bad chart. Yes, you could look at it and work out what it meant, but it doesn't jump out at you. I've harmonized it. It's still a bad chart. When I look at this, I see broken spaghetti. The problem with that is, if my brain sees broken spaghetti, it's not looking for trends, it's not looking for patterns, because a broken spaghetti to my brain means a mess. And so, again, it's a bad chart. Technique number 6 is to use small multiples, that is, have lots of little charts in a table layout. Now, a chart like this has some quite great benefits. The first one is we've gotten rid of colour, so we've created a chart in 2 dimensions, which our brain finds easy to see. The second benefit is that we've compressed the various plots, and so now each of the little lines looks like a pattern rather than a long flat bit of spaghetti, and so our brain is better able to interpret what it means. And the third benefit is we've essentially decoupled 2 bits of information. Each of the little lines tells us the trend, but if we want to look for the overall difference between brands, we can just look at the height, and it's really clear that brand K is consistently really high, whereas something like brand C is consistently really low. So we have two quite different ways of interpreting the chart. Technique number 7 is to bring colour back into play. But the way we bring it back in is to emphasize rather than as an additional series. So here I've used it to highlight the one brand which has a statistically significant movement over the course of the data. Now a chart like this is quite common to be found in academic journals. It's very rare to see it in industry, and I think there's a good reason for this, which is a chart like this is great for understanding the overall relationships in the data, and academics tend to be concerned with relationships. Commercial researchers and users of commercial research, however, tend to have a slightly different focus. They want to understand relationships and trends, but to an extent it's a value add. The real goal of tracking research is often to work out where we are this month and perhaps have we moved since last month. And those two critical bits of information are omitted from this particular chart. Or I shouldn't say they're omitted, you can find them but they don't jump out. Which leads us to technique number 8. What I've done here is I've created a column chart. Because the column chart is one way of representing Net Promoter Scores. It puts, in this case, the most recent wave's results front and centre as bars, or columns I should say. I've still got the trend data, but it's at the base of the chart. On top of each of the columns, I'm showing the most recent wave of results, and colour-coding arrows showing statistical significance. So we can see the brand C has moved significantly up since the previous wave, but it's still at an NPS of -56. The long-term trend we can see is one of decline. So the improvement in the most recent wave is really against a pretty bad history. And so this chart, once it's explained to us, allows us to very quickly see the story, which is this data is primarily about brand C, although brand I appears all over the shop. Perhaps it has a small sample size or something like that. Of course, this chart is not perfect. I've also broken the contract about the meaning of columns. I have positive and negative things shown as a column. And of course, any chart needs to have some compromise, and maybe somebody can work out how to improve this one. Not maybe, I'm sure somebody can. The idea of having lots of small charts, be they on the base of a chart or elsewhere, is by no means new. This magnificent chart is more than 200 years old. It plots the economic history of the world, and it's done by a brilliant man called William Playfair. Each of the area plots that we're looking at here shows the size of an economy over thousands of years. If we look at the top left-hand corner, we can see that the USA's economy is very new, and it had a massive depression, which coincides with its war of independence. Beneath it, we can see that Russia has been steadily increasing, and if we go a bit further down, we can see the sad history, well, not sad history, the cyclical history that was France. I'm going to return to this plot in a second. But I want to emphasize something really key about this plot, which is he created a plot that many of us, and particularly me, wouldn't have come up with. The librarian in us would have, or me again, I shouldn't judge you, the librarian in me would have come up with a different chart. I would have been tempted to organize all of the data alphabetically. And when we organize it alphabetically, we have a chart that's really difficult to use. It's very difficult to interpret the pattern. It doesn't matter how much time we do, we have to keep looking at it and trying to figure out what it means. Now we all know that alphabetical order is not a great structure for a chart. So why is it that we tend to do charts like this alphabetically? It's because there's no obvious way to sort it. But what Playfair did was he used a technique that the French refer to, and I'm not even going to try to say it in French, as diagonalization. And the basic idea is you rearrange the chart so that as close as possible it forms a diagonal line. And when you do that, our brain processes as a single image. It allows us to refer to that overall shape and see interesting patterns. We can see, for example, that there's a massive period of time, the Dark Ages, where there were no economies in the known world, from Playfair, which obviously excluded Asia. The ancient world, there's only Constantinople and Spain bridging the gap to the modern world. And so the 9th technique, and I think the most interesting one, is that we should reorganize data so that it resembles familiar patterns, because by reorganizing data in that way, our brains are able to process it a whole lot easier. Here is another plot. I found this one on the internet. It's a beautiful pattern that's been created, but it's a pattern that makes it really easy to see trends, in this case in industry size. We can see all industries that have declined. We can see that capital markets, which is an elbow, is standing out as having had a particularly precipitous short-term decline. This is a standard graphing problem that many people in market research face. It's brand image data. Each column is showing the extent to which different brands are associated with the different attributes. As is pretty common, I've used different colours for each attribute. But this has actually made it quite hard for us to interpret, because the problem is, with a chart like this, the way to read it is to compare the length of the bars or the size of the bars. But by using different colours, our brain is interpreting there as being differences, which guards against what we're trying to achieve. So the first technique to throw it is to harmonize the data. Now the bars in this case are really forms of size, and as I said before, we're not good at doing anything other than vertical and horizontal precision. So the bars in a chart like this are a bit hard on the brain. So I've also shaded them. So the length of the bar and the shading are communicating the same information, which is to say I've used an extra dimension in a redundant way to really reinforce to the brain that we're interested in the magnitude of each of these bars. But it's still a hard chart to appreciate what it means until we diagonalize it. And the chart at the bottom is a beautiful chart in terms of how we can interpret it. Looking at the top two rows of it, we can quickly see that Diet Coke and Diet Pepsi are sleepy, innocent and feminine, but their key distinguishing attributes, or not distinguishing, their key strengths, I should say, are being weight conscious and health conscious, attributes which they share with Coke Zero and Pepsi Max. But Coke Zero and Pepsi Max differentiate themselves on being open to new experiences, being perceived as rebellious, whereas Coke and Pepsi are down here on older and traditional. And we can also see a whole lot of second level types of insights from looking at this chart. We can see that Diet Coke, it's still got a little bit of older and traditional, which isn't surprising. So by applying the techniques to a complicated chart like a brand image association chart, we can come up with a chart that the brain just finds a whole lot more easier to interpret. And my final slide just summarizes or repeats the 9 previous steps. So thank you.